So maxima and minima with differentiation. So if we think about any curve, when we get to a maximum point, we discover that the gradient of the curve is 0 because it's horizontal. And the gradient we know we find by differentiating. So if we've got any curve, y is a function of x, then when we differentiate and set it equal to 0, we can find out if we have a maximum point. But it doesn't necessarily guarantee we have a maximum, because if we think about a minimum point, that also has a gradient of 0. So in order to discover whether we've got a maximum or a minimum, we have to go a stage further, and that's in another video. A third possibility is that it's neither, but that the graph just momentarily has a gradient of 0. And that's called a point of inflection. So we've got a maximum, a minimum, or a point of inflection. And all these three things are all called stationary points. So the way to test for a stationary point is to differentiate and see if the gradient is 0 at that particular point. We're going to concentrate for now on maxima and minima and in particular situations. So this is an issue for business where you have limited resources and you want to maximize what you can get from them. So we've got a can of dog food with a volume of 500 cubic centimeters, and they want to make sure the surface area of the can is as small as possible given the radius is r and the height is h. So let's start with a little sketch of this can. So we know the radius is r and the height is h, and we're told it contains 500 centimeters cubed. So the volume of a cylinder is pi r squared h, and that must equal 500. We're wanting to find something about the surface area. So the surface area of a cylinder is 2 pi rh for the curved part plus a circle on the top and the bottom, so 2 pi r squared. Now we want this expression of s in terms of r only, and we've got it with an h. But from what we know about the volume, we can find out what h is in terms of r, because by rearranging we get h is 500 over pi r squared, and we can substitute that fact for our h in our equation. So our formula for s is 2 pi r, h is 500 over pi r squared plus 2 pi r squared. Simplifying, that gives us s equals 1000 over r plus 2 pi r squared. Now we can find the maximum surface area. So we want minimum surface area so we can maximize profits. So we want the minimum of this function. So we've got 1000 over r, which we write as r to the -1 plus 2 pi r squared. We then differentiate and we get -1000 r to the -2 plus 4 pi r. And we want this to be minimum, so this has to equal 0. So rearranging, we get 4 pi r equals 1000 over r squared. So r cubed is 250 over pi, and r is the cube root of 250 over pi. That's our value for r that will give us the smallest surface area. So our surface area, our minimum surface area, actually it wants the dimensions of the can, so we've already found the radius, and we want then to find the height as well, which is 500 over pi r squared. So we can now dig out the calculator and find out what our radius is. So the cube root of 250 divided by pi is 4.30 to 3 sig fig, and therefore our height is 500 divided by pi times that answer squared, 8.60 to 3 sig fig, and that would give us a surface area of 1000 times r divided by our radius plus 2 lots of pi times our radius squared at 349 centimeters squared to 3 sig fig. So the underlying rule for all of these questions is to find the derivative, so ds by dr, and set it equal to 0. Let's look at a second example. So this time we've got a cuboid tank which is made from 54 square meters of metal. The tank has a horizontal base and no top, and the height is x. Two opposite vertical faces are squares, so this must be x as well, and then this is a length we don't know. But we do know that the surface area is 54 square meters. So the surface area is made up of two square ends, so 2 lots of x squared, and then 3 rectangles, the 2 sides and the base, which are all x times y. And we know that equals 54, so we can get y in terms of x. So y is 54 subtract 2x squared all over 3x. We can then find the volume, because volume is length times width times height, so x squared times y, and we now know what y is. So I've got x squared times 54 subtract 2x squared all over 3x, which is 18x subtract 2 over 3x cubed, as expected in the question. To then find the max or min, so for maximum or minimum we always differentiate. So when we differentiate 18x we get 18. When we differentiate negative 2/3 x cubed we get negative 2x squared. That needs to equal 0. So 18 equals 2x squared. So 9 equals x squared. So x equals 3. Or negative 3, and it's obviously not negative 3 because you can't have a cuboid with negative side. And then we can put that back into our volume formula. So 18 lots of 3 subtract 2/3 of 3 cubed equals 36 centimeters cubed. Justify that we've got a maximum. Well, we'll come on to another method later on, but if we just change x a little bit, so if we make it slightly more, 30.1, we should find that the volume goes down. And it does, it goes down to 35.93. So we must have a maximum.